Hi and Assalamualaikum. Today I will be presenting for task 2 assignment 5 for the subject of Introduction to Mathematical Economics. I am from group C. I am preparing this for Madam Nurusita binti Jamil. Biodata. My name is Muhammad Ariff Rusyaidi bin Roslan. My matrix number is 265563 and I am from group C. My course is Bachelor of Industrial Statistics. I am currently in semester 7 and my academic qualification is matriculation. For the first question, question 1a, determine where the function f(x) equal to x to the power of 3 minus 6x power of 2 plus 18x minus 15 is concave outward and where it is concave downward. So first, we differentiate using the power rule. So the function is x to the power of 3 minus 6x power of 2 plus 18x minus 15. The first derivative is 3x power of 2 minus 12x plus 18, and the second derivative is 6x minus 12. Next, let f double prime x equals to 0. F double prime x equals to 6x minus 12. 6x minus 12 equals to 0 equals to 6 times x minus 2 equals to 0 and x equals to 2. So we can get the interval which is negative infinity to 2 and 2 to infinity. So next, test the number in the interval to identify where the function concave upward or downward. So for the first interval, negative infinity to 2, we can choose a number between the interval and I choose the test number of negative 1. So the value of test number when plugged in into the f prime x, we get a value of negative 18. And we can see that the sign is negative. So for the concavity, for the second derivative of the function, we get f double prime x is less than 0. Same goes to the second interval, 2 to infinity. The test number I have chosen is 3. The value of f prime x, when plugged in the test number, we get 6. The sign is positive and the concavity is f double prime x is more than 0. And next, determine the function concave upward or downward. So from the last slide, we can see that for the first interval, negative infinity to 2, we get the concavity of f double prime x less than 0. And for the second interval, 2 to infinity, we get the concavity of f double prime x more than 0. So for the rule, we can see that if f double prime more than 0, f is concave upward in the interval. However, for f double prime less than 0, f is concave downward in the interval. So we can conclude that since f double prime more than 0 for each value of the x in the interval of 2 to infinity, then f will concave upward in the interval. And since f double prime less than 0 for each value of x in the interval negative infinity to 2, f will concave downward in the interval. Now, the next question, question 1b. Suppose that the cost function for a manufacturer is given by Cx equals to 0.000001x to the power of 3 minus 0.003x power of 2 plus 5x plus 1000. Describe the behavior of the marginal cost function. For the question 1 Roman, find the marginal cost function. And for the second Roman number, describe the behavior of the marginal cost function, whether concave upward or concave downward. Prove your answer. So for the question B1, to find marginal cost function, the cost function needs to be differentiated. So we get Cx, the original function, equals to 0.000001x to the power of 3 minus 0.003x power of 2 plus 5x plus 1000. C prime x equals to 0.000003 x power of 2 minus 0.006x plus 5. And now for the question B2, to find the concavity, C double prime x needs to be done and find the interval. So from the previous question, we have done C and C prime x. Now we will do C double prime x. And the answer is 0.000006x minus 0.006. Then let C double prime x equals to 0. So 0.000006x minus 0.006 equals to 0. Then we add 0.006 to both sides, then we get 0.000006x equals to 0.006. Then we will get x equals to 0.006 over 0.000006. Then we will get x equals to 1000. So the interval is negative infinity to 1000 and 1000 to infinity. After that, test the number in the interval to identify whether the function concave upward or downward. For the first interval, negative infinity to 1000, the test number that had been chosen was 500, and when 500 plugged in into the function f prime x, we get negative 3 over 1000. So the sign is negative and the concavity is f double prime x less than 0. And for the second interval, 1000 to infinity, the test number that had been chosen was 2000, and when plugged in into f prime x, we get 3 over 500. The sign is positive and the concavity is f double prime x more than 0. So from the previous slide, we can see that negative infinity to 1000, we get the concavity of f double prime x less than 0, and for the second interval, we get f double prime x more than 0. If f double prime x more than 0, it concave outward in the interval, and for f double prime x less than 0, the function will concave downward in the interval. Since f double prime x more than 0 for each value of x in the interval 1000 to infinity, it will concave upward in the interval. And since f double prime x less than 0 for each value of x in the interval of negative infinity to 1000, then f will concave downward in the interval. And for the last question, question 1c, a company has established that the revenue function in Ringgit Malaysia is Rx equals to 2x power of 3 plus 40x power of 2 plus 8x. And the cost function in Ringgit Malaysia is Cx equals to 3x power of 3 plus 90x power of 2 plus 80x minus 800. So find the level of production that will yield a maximum profit for the company, and then find the price per unit to maximize the profit. For the first one, find profit. Px equals to Rx minus Cx. So Px equals to, we put in Rx and minus the function with Cx. We get negative x power of 3 plus 21x power of 2 minus 72x plus 800. Then we find P prime x, we get negative 3x power of 2 plus 42x minus 72, or P prime x. Then let P prime x equals to 0. Then we will get x equals to 2 and 12. Now to maximize the profit function, we get the second derivative of P function, we get negative 6x plus 42. So when x equals to 2, P double prime 2 equals to negative 6 times 2 plus 42. So we get 30 more than 0 and it's the minimum value. And when x is 12, we get 30 less than 0 and it is the maximum value. Since P double prime x less than 0, when x equal to 12 is the maximum profit, we get the level of production that will yield the maximum profit is 12. And for the second question, find price per unit that will maximize profit. So when level of production equals to 12, plug in 12 into the profit function, we will get 1232. So price per unit equals to 1232 over 12. We get price per unit is 102 ringgit and 67 cents. Therefore, price per unit to maximize profit is RM 102.67. And that's all from me. Thank you.